Okay, hello everybody. Good evening. Can you hear me? Can you hear me? If you can hear me properly, please tell me. Okay, great. Okay, without wasting time, let's go to the lesson. So last week we did binomials. So from the what you call from the exercises or the tutorial that I sent you or from the textbook, if you have any questions, you can send me on the chat. I will do it. But before that, so as a summary, last time we did multiplication of binomials. So if you have something like this, what you always do, you multiply this with this, this with this. So when you multiply this with this, you get 2a plus 2b. Then we have multiples of two binomials. So in that case, the first term with the first term gives me x squared. The first term with the second term gives me 3x. This one gives me plus 2x. And at last, it gives me 2 times 3, 6. So if you summarize the answer, you can get x cubed, x squared, the like terms you can add. So 3x plus 2x is going to give me 5x plus 6. Then for square, you learn it is going to be first term squared plus 2 times the first term times the second term plus the second term squared, 2 squared. So that is going to give me x squared plus 4x plus 4. Then we have cube. We also learned about cube. So that is going to be the first term cube plus 3 times the first term times the second term plus 3 times the first term times the second term. So you need to square each term, right? So square square plus the third term cube. So this thing also you can write x cubed plus 9x squared plus 3 times 3, 9, 27x plus 27. So I hope this is all like I think last time we did 2 lessons, right? From grade 10 and grade 11. So this is the content, right? So if you are okay with these 4, then you are good to go to the next lesson. So I don't see any messages requesting me to do any questions. So I guess you are okay with this content. Okay. Yeah. Fine. Let me erase this. Okay, so today we will be looking into the 3 lessons, actually 4 lessons with grade 11. So first, let's check on factors of algebraic expressions. Okay, so this is a lesson from grade 10. This is a lesson from, okay, student is telling not clear. I think please check your network. Because I think the screen is pretty clear. You can check your network, maybe on your network issue on your side. Okay. So factors. So what are factors? So I will start. So basically we will cover, this is a very small lesson. There's nothing complex. So 30. So if you say the factors of 30, that means you have to write this number as a multiple of several numbers, right? So for example, 30, you can write like, let's say 2 into 15, right? 2 into 15. Then 2 you cannot break anymore, right? Or anyways, you can write 1, 2, you can write like 1 times 2 times 15. Then 15, you can maybe write like 2 times 5. Sorry, 3 times 5, right? So 3 times 5. Then I don't think anywhere you can break again, right? So the factors of 30 are 1, 2, 3, and 5, right? So this is called the factors. So let's write for binomials, right? So let's think something like 3 times x plus 12. Sorry, 3x plus 12. 3x plus 12. 3x plus 12. Can you factorize it? You are going to tell me the answers, or you can send on the chat. What will be the answer? 3x plus 12. You need to break it into factors. Easy one. Okay, we have one answer. Yeah. So whenever you need to break from factors, what do you need to do? Just check 3. So how to make 3? 3 means like what you say, 3 times x, right? 3 times x. So this is very basic. Then 12. So 12 means what? 12, maybe you can write 2 times, or else like you can write as a 3, right? You can write 3 times 4, right? 3 times 4. So in this case, you can see this 3 is common, right? This 3 is common. So here also he got a 3, and the second term also got a 3. So then in that case, you can take the 3 outside. So when you take 3 outside, here 3 goes outside, then x is remaining, plus the 3 goes outside, the 4 is remaining. So that is why we are telling, when we take 3 outside, it is going to be x plus. So it is a multiplication, right? So in between, you don't write anything, means there's a multiplication. Great. So this is a grade 10 work only. So anyways, then number 3, write them down. P squared minus p. P squared minus p. This is revision actually. P squared minus p. What would be the answer? Quickly. Okay, we have one answer here from Sangit J. So again, p. P means what? P times p, right? And here, sorry, p squared means p times p. And here we have a p, right? So again, 1p is common, right? 1p is common. So here he got 1p, here he got 1p, and here he got 2p's. So maybe I can take 1p outside. Then if I take 1p outside, another p is remaining here, minus, and here I'm taking the p outside, so nothing is remaining, right? So that means 1. P times p minus 1. Yes, exactly. Okay. So here we got 1, right? So when you take that, because p is made by p times 1, right? P times 1 means p. So when you take the p outside, 1 is remaining. Actually, it is minus p, right? So it is going to be p times minus 1. P times minus 1. So when you take p outside, minus 1 is remaining. Great. Next one. Fourth one. Let's say 4pq, 2pq minus 2pq minus 4p squared q. 4p squared q. 4p squared q. Let's find it quickly. Okay, let's see who is the first to get the answer. Okay, we have one answer from Rumana and then Shagin J. Okay, so here 2PQ means 2 times P times Q, right? 2 times P times Q. And here minus 4PQ means minus 1 times 4 times P times P times Q, right? P times P times Q, right? So you can check what are common. So here we have a 2 and here 4 means 2 times 2, right? So here we have a 2 or over here. So when you take it, there will be 1, 2 remaining. Then we have a P, we have a P and Q also there, right? So you can take 2PQ outside, I think, right? You can take 2PQ outside. Let me check the answers. Okay, you have. Okay, great. So 2PQ we have common, right? So what happens? You take 2PQ outside because it is 2 and a P and a Q are common. You also got the same. So here I'm going to take everything, right? So 1 is going to be remaining. And then here minus, right? It is minus means minus. Minus what is remaining? So here I had a 4, that means remaining 2 because I already took 2 outside. Then this P I already took out. This P again remaining, right? Yeah, 1 P is remaining. So it is going to be P and this Q is going to remain. It's going to be 1 minus 2PQ. So that is going to be the answer. If you need any explanation, tell me. I'm just roughly going through them. I hope you know these things. So if you want any explanation, tell me on the chat. Oh yeah, I did a mistake. Yeah, right. So you took Q outside, right? So this is not going to be there. Yes, Shangudi, you're right. So it is going to be 1 minus 2P. Yeah. 1 minus 2P. Okay. And then number 5. Number 5, let's do a different one. So we have 2A squared minus 8AB minus 2B squared minus 8AB. Okay, let's do that. So only difference is we got 3 terms. So here we got 2 terms, but here we got 3 terms. So that is the only difference. Okay, we have one answer from Asmatullah. Okay, and also Kiturshan. Okay, so here we can check. Here we have a 2 times A times A. Okay, I'm not recommending you to write it, right? So you can see I'm just writing this to explain you. So here we have 2 times A times A. Here we have minus 8 times A times B. And here we have minus 2 times B times B, right? Okay, so now you can check what is common. So here we have a 2. So within 8, you have a 2, and here also we have a 2. Then A is common. Here we have a A, here we have a A. Oh, here we don't have a A, right? So we cannot take A outside. Then what about B? B also we can, here he got a B, but he don't have a B. He's not having a B, right? There's no B here. So you cannot take B also outside. So I think only thing you can take out is 2. So what happened when you take 2 outside? So is equal to 2 outside. So from 2A squared, you take 2 out, the remaining is A squared. From minus 8AB, you take 2 outside, it is going to be minus 4AB. And from minus 2B squared, you're going to take 2 outside, it is going to be minus B squared. Okay, I hope it's clear. Yeah. So you cannot take 2A outside, okay? Because this guy there's no BA here. So you cannot take A from that guy because there's no A. Okay, then number 6. Write down these questions in your book. These are very basic, but still you need to understand. A squared BC plus AB squared C plus ABC squared. Find it. Okay, we got one answer from Saginjay. Okay. We got another answer from Hafsa and also from Rumana. Okay, let's see. So here we have A squared, right? That means A times B times C. Here we got A times B times C. And here we got A times B times C, right? So here we got 2 A's, here we got 2 B's, and here we got 2 C's, right? So, but I can take 1A out, 1A out, 1A out, right? So that means I can take 1A, no problem. Another A, I think I cannot take another A, right? Because this guy or this guy, they don't have A's, so I cannot take more A's. Then I can take B's, right? Here he have B, he have B, he have B. So I'm going to take 1B from him, 1B from him, 1B from him. So B is okay. No more B's, right? I cannot take B's. He don't have B's. Then C. I take a C from him. I take a C from him. I take a C from him. Okay. Now let's write the remaining within the bracket. So within the bracket, the remaining. So from first A squared BC, we have a remaining, right? We have a remaining A plus from AB squared C, we have a B remaining. And from ABC squared, we have a C remaining. So it's ABC times A squared BC plus. Okay. So I think one student sent me ABC times ABC. So it is ABC times A plus B plus C. Okay. Next, number, I think 7. Number 7, let's do x times A plus B plus y times A plus B. Easy one, but very important. This concept is very important for the theory that you're going to learn. Okay, we have one answer from Romana. Okay, Kitrushan, Shagin J. Yes, perfect. Okay, so when you have something like this, so within bracket, right? Within the bracket, we have A plus B. So we consider this as one term, right? For me, A plus B is just one number. It can be 5, like 2 plus 3, 5, right? So it's just one number. So whatever within the bracket is going to be just one number. So I can see this is x times A plus B, right? That is like 2 numbers, right? So here we had like 2 times A squared, right? Same way. This x times A plus B. And here I have y times A plus B. So what is common? Here we have addition. So on the two sides, what is common? A plus B is common, right? So in that case, I'm going to take A plus B outside. So this is x times A plus B. This is y times A plus B. So I'm going to take A plus B out. Same like above example. So nothing different. So I'm going to take A plus B outside. So when I take A plus B outside, what is remaining? From this one, x is remaining. And from this one, plus y is remaining. plus y is remaining. So it is going to be a plus b x plus y. Very simple. Okay. You're going forward step by step. So then number 8, let's write p times 2a minus 3b plus q times 2a minus 3b. That's easy, right? Yes, right. Okay, so we are going to take again the same like this, no difference, right? The only difference is here it is addition, here it is a subtraction. So I'm going to take, this is one term for me. I don't care whatever inside the bracket, right? There can be anything inside the bracket, but it is just one term. But is the term same? Yeah, right? This is 2a minus 3b and this is 2a minus 3b. So I'm going to take 2a minus 3b outside. Nothing to think. So when you take that out, what is remaining? Here I have a p and here I have a plus q. Great. Then number 9, I have, let's do this. 3 plus 3 plus a times b plus 1. Okay, factorize this. Okay, let's do it quickly. Yeah, we have from Romana. Okay. So here we will have just 2 steps, right? So we don't see b plus 1 here, but here we can see like we have a 3 in common, right? But there's no 3 here. So from all the 3 terms, I cannot take a 3 out, but from here I can take a 3 outside, right? So I just use this from here, I will take a 3 outside. So when I take a 3 outside, I have b and plus 1, right? From this term, I take 3 out, and from this one, I take 3 out. So it is going to be b plus 1. Then plus a times b plus 1. So again, same term, same term. So it is going to, I'm going to take b plus 1 outside. When I take b plus 1 outside, what is remaining? 3 plus a. Perfect. Okay, so I'm just quickly doing these examples. And if anyone wants me to further explanation, I mean, explain a little bit more, just tell me on chat, okay? I hope these things are, I'm just doing them very quickly. So next one, m minus 3mn minus n plus 3n squared. I hope everyone is trying also, because if you don't, as I always say, if you don't try, there's no point in a mathematics class. It should be always you who tries. Okay, we have several answers, 1 minus 3n and m minus n. Okay, so let's do like this. So let me take m outside. So because m is common, right? So it is going to be 1 minus 3n. And here also I'm going to take minus n outside, right? I'm going to take a minus n outside because here, so from minus n, when I take minus n outside, plus 1 is remaining, right? And here from plus, this is plus, right? From this plus 3n squared, I'm going to take minus outside, right? So from a plus guy, I'm taking a minus out. So this is going to be, this plus is going to be minus in that case. I mean, from a positive thing, like minus and minus makes up a positive, right? So when you take the one minus outside, then minus is going to remain, right? So here, from a plus guy, when I take a minus n outside, minus is going to be remaining. So then it is going to be 1 minus 3n. So now it is same. So it is going to be 1 minus 3n you take outside, and it is going to be m minus n. Yeah, we have several correct answers. Okay. Okay, how about this? 11th one, x times 2p minus q minus y times q minus 2p. Okay, we have one answer, x plus y 2p minus q, and we have another answer, x minus y 2p minus q. Okay, any other answers? Okay, we have 2p minus q, x minus y, q minus 2p. Okay. Any other answers? Okay, let me do. So keep in mind, so here look, here we have 2p minus q. Here we have q minus 2p, right? They are not the same, but there is a relationship, right? You can see, right? So one is like 2p minus q, the other one is q minus 2p, right? I mean, they are not the same, but there is some relationship, right? There's like exact opposite, right? So one is like a minus b, and the other one is like b minus a, right? Or one is like 5 minus 2, the other one is 2 minus 5, right? But they are not same, right? Because 5 minus 2 is 3, 2 minus 5 is minus 3. Okay, so keep in mind, a minus b can always written as minus b minus a. That means you can take the minus outside. We can take 1 minus outside and write it like the opposite way, b minus a, right? A minus b is always equal to minus b minus a, right? So that means here 5 minus 2, let's take this example, right? So we can write 5 minus 2, right? 5 minus 2 is going to give me what? 5 minus, let's think about 2 minus 5. So 2 minus 5 is going to give me minus 3, right? What about minus 5 minus 2? right? That's what I did, right? I took the minus outside and changed them, swapped them, right? So minus 5 minus 2. So again, 5 minus 2 is 3, and there's a minus, so it is going to be minus 3. Same, right? So these both are same, right? So that is why I'm telling a minus b is going to be equal to minus b minus a, right? So here also you can do the same thing. So here also you can write p minus, here I have a p 2p minus q, right? So here I have q minus 2p. So instead of q minus 2p, let me write it. Q minus 2p, let me write it. Let me write it minus 2p minus q, right? Minus 2p minus q. That means I'm going to take a minus outside. So from 2p, from q, when I take a minus out, it is going to be minus q. From minus 2, when I take a minus out, it's going to be 2p, right? So simply, you can put a minus here and swap the numbers. So this number can, both are same. So they are actually not arrow, it should be equal, right? So here I can write x times 2p minus q. Okay, then I'm going to take a minus out, right? I'm going to take a minus out. Then this becomes a plus, right? This minus times minus is plus, right? So this minus becomes a plus. That means you are going to change this sign. If it is plus, it is going to be minus. If it is minus, it is going to be plus. Then you can just write y times, you can swap them, 2p minus q, right? I hope you understood, because this is minus, they are different. So you just change this sign and you swap them. So it is going to be plus y times 2p minus q. Now they are the same, right? Now we can do continue. Now you can continue. So it is going to be, you are going to take 2p minus q outside. So 2p minus q, when you take outside, x plus y. Okay, so the basic thing is, so it is going to be 2p minus q x minus y, right? Isn't it? X minus y. Okay, it's not clear. You mean the board is not clear or the explanation is not clear? Okay, great. So so here again, look at this. So here we have a 2p minus q. Here we have a q minus 2p, right? So you can see okay, so you can see here I have a 2p minus q, here I have a q minus 2p, right? So they are not same. I mean, here you took them outside, here whatever it is, b plus 1 you took outside, because they are the same, right? It is, this one is b plus 1 and this one is b plus 1. So it is common, so that is why you took it out. But here they are not common. Here I have a 2p minus q, okay? Here we have a q minus 2p. So they are not same, but somehow if I can make them the same, then I can take outside, right? So to make them the same, I can do one thing, right? Instead, I can do the inverse thing, right? So here I have a 2p minus q. So you can change this sign, right? You can change this sign. If it is minus, you are going to write a plus here. So you can change this sign and swap these two numbers. So 2p minus q. So that means if it is a minus b, you can write it as minus a plus b minus a. Okay. So if it is, for example, let's say x minus y, you can write, okay, if you have minus x minus y. So this will be always equal to the set. So this minus will become plus and this will become y minus x. Okay, so that is what I did. So here it was minus. So this minus, I make it a plus and I swap the two numbers. So here q minus 2p, I made it 2p minus q. But when I do that, this will change. Whatever it is here, it will change. So that is why I make a plus. So now here I have a 2p minus q. Here I have a 2p minus q. You take 2p minus q out. Then I have a x here. And here I have a, sorry, here it is a plus. Yeah, I'm sorry, my bad. So here it is a plus. So when you take 2p minus q out, it is going to be x plus y. I hope it's clear. Okay. So always you change this sign and swap the numbers. Okay. Then let's do, what did we do? Question 12, 11, right? Let's do 12. So these basic concepts you need to understand. Then when you're going forward, it is going to be very easy. So when you know the basic rules and these things, later it is going to be easy, right? So even in like previous binomials, the cube and square is very easy, right? So likewise, you should know the basic theory, then going forward is going to be easy. If you don't know the basics, then going forward will be very difficult. So let's try this. Okay, 3x minus 2 times 2a minus b, 3x minus 2, 2a minus b. Awesome. Okay. So here also it is going to be same, right? So here we have a 2a minus b. Here I have a b minus 2a. So now I need to swap them, right? So I mean to make them the same. Here I have a 2a minus b. Here I have the exact opposite, b minus 2a. So what should I do? 3x, I will write this thing as it is, 2a minus b. Then I will make it negative. Why I make it negative? Because I want to change it to 2a minus b, right? Then it is going to be same. I'll take 2a minus b outside. So it is going to be 2a minus b and then 3x minus 2y. Okay. Yeah. Okay. Don't, I mean, write it down. So these are like examples. So number 13. M times L minus 2n minus P times 2n minus L. Okay, we have L minus 2n M plus P from Kitushan. Okay. And also, okay. So same thing. So we have M, L minus 2n. Then again, you can see this one is L minus 2n. This is 2n minus L. That's sub. So what will I do? I will change it to minus. I will make it a plus P L minus 2n. So now they are the same, so I can take it out. So L minus 2n m plus b. Okay, so let me check the answers. So m plus b, L, yeah, all of you got correct. Yeah. Then 9th one. Sorry, not 9th, 14th. 14th one. K times 2x plus y, think carefully, minus L times y plus 2x. Yes, we got 2 correct answers. Okay, so look carefully. So here it is 2x plus y. Here it is y plus 2x. But are they the same? I mean, if I say 5 plus 2, and here I say 2 plus 5, 5 plus 2 is 7, right? 2 plus 5 is 7. So both are same, right? Even if I say 5 plus 2 or 2 plus 5, ultimately I'm going to get the same answer. So 2x plus y and y plus 2x are the same, right? So in this case, you don't need to swap, right? Only if there's a difference, something minus something. Positive number minus negative number, in that case only you need to swap. So here you don't have to swap. I mean, instead of y plus 2x, you can say 2x plus y, right? I mean, 1 plus 2 is equal to 2 plus 1, right? So same way, if it is addition, you don't need to change this. So look, here I can write 2x plus y minus L times 2x plus y, right? Without changing this, I can just change it, right? I can just write it. Y plus 2x means 2x plus y. There's no difference. So I can take 2x plus y outside. So 2x plus y outside. And here a k is remaining. And here a minus L is remaining. Okay, so for the students who sent k plus L, did you understand? Did you understand why we are not swapping? Okay, great. Okay, 2 more. 14, 15 is going to be a x plus 3y minus b minus x minus 3y. Minus x minus 3y. Something happened to the board today. Better now. Okay. So we have a plus b, x plus 3y. Okay, 1 answer so far, 2 answers. Okay. So look, here there's a minus, here there is a minus. Here both are negative and here both are positive, right? So I'm going to take a minus outside. I'm going to take minus 1 outside, right? From this one, I'm going to take minus out, and from this one, I'm going to take minus. Since here I have a minus already, so minus times minus, right? It is going to become plus, right? So then when I multiply a number with minus, my sign is going to change. So in that case, I can write a times x plus 3y. I take minus out, so minus and minus going to be plus b times x plus 3y. So now you can take x plus 3y outside. So x plus 3y, when you take out, a plus b is remaining. Okay. Then the last one under this revision exercise, we have b m minus 2n plus d times 2n minus n. Easy, I think, right? Okay, plus b minus d 2m minus n. Okay, so here we need to swap, right? So I will change the sign. So it is going to be b. Sorry, I'm going to take 2 m minus n. Oh, sorry, b m minus 2n plus, right? So here I'm going to take the minus out. So I'm going to swap. I need to swap, right? So I will make it minus d times m minus 2n. So I take m minus 2n out. So m minus 2n. What is remaining? I have a b here and I have a minus d here. Done. Okay. Then now we are coming to important part. Factors of trinomial quadratics. Factors of trinomial quadratics. So factors, now you know what are factors, right? So now you know how to find the factors. Now, what are trinomials? So last week we did binomials. So binomials means there's going to be two types of terms like x plus 2 or a plus b. So these are binomials. Trinomials means there are three types of terms, right? Like a x plus 2 plus y or a plus b plus c. So three types of terms that cannot be added to each other. Then again, quadratics. So quadratics means like there are expressions like, let's say you're multiplying, let's say x plus 2 times x plus 3, x plus 2 times x plus 3, x plus 2 times x plus 3. So how to multiply? Under binomials, we learned this one times this one, x squared. This one times this one, plus 3x. This one times this one, plus 2x. This one times this one, plus 6. So that gave me x squared plus 5x plus 6. So this is called a trinomial quadratic expression. So if we, in a quadratic expression, this is a quadratic expression of x, right? So in a quadratic expression, the first term is going to be a x squared term, right? X squared is there. The second one is going to be a x term. And the third one is going to be a constant. That means no x. So here they are going to be a x squared term. Here there is going to be a x term. And here it is going to be a constant. So this is called, I mean, in any expression, if you find x squared term, x and a constant term, so x squared term, an x term, and a constant, we call it a quadratic, trinomial quadratic expression. Okay. So in a quadratic expression, we have some numbers, right? Before x squared, we have some numbers. In this case, it is going to be 1. So here also we have a 5. And this is constant. Anyways, this is constant, right? So here we call these terms coefficients. Coefficient of a, the coefficient of x squared, the coefficient of x. We call them the coefficients. Okay, so here we have x squared term, the coefficient is 1. Here we have x term, the coefficient is 5, and here we have a constant term, which is 6. Okay, but now we know what are quadratics. Quadratic means there should be a square term and a to the power 1 term and a constant in this form. Then a trinomial means there's going to be 3 terms. This is 1 term, x squared term, this is x term, and this is constant terms. So there are 3 types of terms, right? So these types of terms are called trinomial quadratics. Finding factors. Finding factors means, so this is a trinomial expression, right? So this is a trinomial expression, trinomial quadratic expression. So finding factors means this expression you need to express as a multiplication of 2 numbers. So here we express this number, which is like in between I have addition, right? But here this one plus this one, right? Here this means this thing plus this thing. So this is addition of 2 terms, right? So here this addition I expressed as a multiplication of 2 terms. I expressed as a multiplication of 2 terms, which means I have found the factors. So factors of this entire thing are going to be m minus 2 is one factor, b minus d is going to be the other factor. So finding the factors of this one means I need to express this as multiplication of 2 numbers. I don't know what are those numbers, so I'm going to express them as multiplication of 2 numbers. So here, if you go back, you can see you got these 2 numbers by multiplying these 2 numbers, right? You just multiplied x plus 2 and x plus 3 to get this. So obviously, in this case, since you know how you got it, the factors are going to be, this is going to be one factor, and this is going to be another factor, right? So in this lesson, we are going to learn how to find the factors. So this is again, this is once again from grade 10. Okay. So let me erase this. So generally they start from where this one is 1. So let me start from where this is not 1. So let's say let me check any number where we have factors. Okay, so we have 2x squared plus 5x plus 2, right? 2 times 2, 4. Okay. So you need to find the factors of this expression. Okay. So I know some of you may be able to do this, but still I will explain first. So what you need to do is you need to check the coefficient of x squared term, right? You need to check the coefficient of x squared term, and you need to check the coefficient of, the constant. So here the coefficient of x squared term is 2, and the coefficient of constant, not the coefficient of constant, the constant is 2, right? So you are going to multiply these 2 numbers. You are going to multiply these 2 numbers. So when you multiply those 2 numbers, what do you get? So you get 4, right? That means 2 times 2, 4, right? So 4. So it is plus 4, right? Here I have a plus number. Here the constant is plus 2. So plus 2 times plus 2 is going to give me plus 4, right? Plus 4. So what are the factors of 4? I'm going to write each and every factor of 4 here. So this is not part of the sum, this is rough work. Whatever I write in red is not required. To write when you solve a question, it is not required. This is rough work. So how to make 4? 1 times 4. Or 2 times 2. Or 3 times I cannot make a 4. 4 times 1. 4 times 1. Here I already wrote 1 times 4. I'm not going to write 4 times 1. But there are more numbers. -1 times -4. or minus 2 times minus 2, right? So all these terms will give me plus 4, right? All these are factors of plus 4, right? So then you have to check, you are going to add them. So when you add these two, then you can get a 5. So here the coefficient of x, the middle term, the coefficient of the middle term is 5, right? So you are going to check when you can add these two numbers to get a 5. So 4 plus 1, 5. Okay, done. So I'm going to select this, right? So these are anyways wrong, right? 2 plus 2 is going to give me 4. Minus 1 and minus 4 going to give me minus 5. Minus 2 and minus 2 going to give me minus 4, right? So this is the one that I selected. Then I select 1 and 4, right? So then I'm going to write the exact same thing, 2x squared, but 5, I'm going to break it into two parts, 1 and 4. So I will write 1 means 1x, right? That means x plus 4. So 4x plus 2. X squared plus 4x plus 2. Azim, sir, the last term is 4. No, sorry. Yeah, the last term is 2, Azim. This is 2. So 2 times 2, 4. That is why we took 4. Okay, so here we have x, 4x plus 2. Okay, so now you check which you can take out. So you consider these two separately, right? So you are going to take, here you can see we have a 2 and 2 x's. Here we have 1 x. So I think we can take only x outside. So when you take x outside, what is remaining? So from 2x squared, you take x out, x is remaining. Sorry, 2x is remaining, right? 2x is remaining. And from x, you take x out, only 1 is remaining. Then from here, plus 4x plus 2, what you can take out? You can take a 2 outside, right? Here I have a 2. Here inside 4, there's a 2, right? So I can take 2 outside. What is remaining? 2x plus 1. 2x plus 1. So now you can see here I have a 2x plus 1. Here I have a 2x plus 1. I can take 2x plus 1 outside. 2x plus 1 outside. So when I take 2x plus 1 outside, what is remaining? Here there's a x remaining and there's a 2 remaining. Is it clear? Okay, so let's do an example. So first one. Okay, let's make this one the first one. So from this example, like in your grade 10 theory books, there are 3 sections, right? It is broken into 3 parts. So from this example, actually, I taught all the 3 by using one example. So I think we can move on to doing exercise. So when doing exercise, if you have any doubts, we can clarify. So first one, x squared plus 5x plus 6. X squared plus 5x plus 6. Always remember, you need to multiply this one with this one. So if there's nothing there, means it is going to be 1. So 1 times 6 is 6, right? But here we had a 2 here, so that's why we multiplied with this one. So always multiply this one with this one. So let's find the answer. Write this down and find the answer. Okay, we have x plus 2, x plus 3. Yes, right. So this is number 2. We have x squared let me erase this side. X squared plus 5, x plus 6, right? So number 2, we have x squared plus 5x plus 6. So again, for 6, so 1 times 6, right? 1 times 6. So you have 6. So what are the, how to make 6? 1 times 5. 1 times 6 is 6, right? So from this one, can I make a 5? No, right? We cannot make, right? When you add 6 plus 1, it is going to be 7. So by addition, we cannot make a 5. Then we can write 2 times 3. 2 times 3. So 2 plus 3 is going to give me 5. Yeah. So I will select this. No need to go further. So in that case, I can write x squared plus 2x plus 3x plus 6 is going to give me what? So this thing, right? 2x plus 3. So I selected 2 and 3 because of this 2 and 3. So then I'm going to take x outside, is going to be x plus 2 plus, I'm going to take 3 outside, it is going to be x plus 2, right? So from this, I am going to take x outside. So x is remaining. From 2x, 2 is remaining. From this one, I'm going to take 3 outside, x plus 2. So now I'm going to take x plus 2 outside. So x plus 2, x plus 3. Simple. Okay, next one. Number 3, 6 minus x minus x squared. 6 minus x minus x squared. 6 minus x minus x squared. Okay, what did I have to do? 6 minus x squared, right? Yeah, 6 minus x squared. Okay, yeah, we have several answers. So here I'm going to write this in my normal format, right? Because I used to write, first I'm going to write x squared, then a x term, and then a constant, right? So here also I'm going to write minus x squared minus x plus 6, right? Okay, so then I'm going to multiply this and this, right? So it is minus 1 and 6. So minus 1 and 6 is going to give me minus 6, right? Minus 6. Why minus 6? Because there's a minus 1 and here it is a plus 6. So when you multiply, it is going to be minus. So what are the factors? So it is minus 1 times 6. Minus 1 times 6. When you add, are you getting minus 1? No, incorrect. So minus 2 times 3. 3 plus minus 2. It is going to be plus 1. Wrong, because I need minus 1 here. Then minus 3 times 2. Minus 3 times 2. When you add minus 3 and 2, I'm getting minus 1. So in that case, I can use this 2. So what it would be? So I can write x is equal, this is equal to x squared minus 3x plus 2x plus 6, right? Minus 3x plus 2x plus 6. Then from this one, I'm going to take, here I have minus x squared, here I have a minus 3x, so I'm going to take minus x outside. So when you take minus x outside, what is remaining? Here x is remaining, and here a plus 3 is remaining. From here, you are going to take a 2 outside, x is remaining, and a 3 is remaining. Now you're taking x plus 3 outside, x plus 3 outside. So what is remaining? Minus x plus 2. right? So now you can change, if you want, you can change the sides and write x plus 3 times 2 minus x. Is it clear? I got only two or three answers. I got only 3 answers. Other students, is it clear? Okay, we got one no. Okay. What is the problem? So the same method we are using. So till that I will explain again. So till that other students can try this. The students who understood can try this one. Third one can try a squared minus 4ab minus 5b squared. So the students who did not understand, look at me, look at the board. Other students try this question. Okay, let me take a different example. So let's say I'm going to take so x squared minus 5x plus 6. So if you want to do this one, what you'll do, you multiply this number with this. When you multiply here, I have a 1, right? So multiply 1 times 6. So 1 times 6 is going to give me 6, right? Then I'm going to find the factors of 6. So what are the factors of 6? It is going to be 1 times 6. Okay, so from 1 and 6, when you add them, so 1 plus 6, is it giving me minus 5? No. So I cannot take this one. Then I'm going to the next factor, like 2 times 3. 2 times 3. So 2 plus 3 is going to give me minus 5? No, right? 2 plus 3 is 5 plus 5. So this is also wrong. Then now let's think about minus numbers. All the plus numbers are finished, right? So now let's think about minus numbers. So again, I need to make plus 6, right? So minus 1 times minus 6. So again, minus 1 and minus 6 is going to give me minus, when you add them, it is going to give me what? Minus 7. So in that case, I cannot take this one also. Then I can take like minus 2 times minus 3. So when you add these two numbers, minus 2 plus minus 3, I am getting this one, right? I mean, simply check whether when you add these two numbers, whether you're getting this one or not. So here you get this number, right? Minus 5. So in that case, you can write, you will select this one, right? Minus 2 and minus 3. So now we are going to break this 5 into 2 parts. So it is going to be x squared minus 2x minus 3x plus 6, right? So now, so that's it. That's a new part. So this 5 I broke into 2 parts, exactly, right? Minus 5 I broke into 2 parts because of this, minus 2 and minus 3. So in that case, what do? I take x outside, so x minus 2, right? Here I have x squared. From this one, I get this. And from here also, I take a minus 3 outside. When you take a minus 3 outside, what happened? There's a x remaining, and here it is going to be a minus 3. Right? Sorry, minus 2. So then you take x minus 2 outside. Same, right? X minus 2, x minus 2. You take x minus 2 outside. Then what happened? X minus 3 is remaining. Did you understand this question, the students who did not get the previous part? Okay, great. So let's look at this one also. So here also, you can see we have a minus 4ab minus 5b squared. So as I told, always, now this is a quadratic expression of a, right? Let's write a. Also, you can write this as a quadratic expression of b, no problem with that. But here I will think it is a quadratic expression of a. So here we have a squared, here we have a, and here we don't have any a terms. Done. Then here we have a 1, right? This is a 1. So 1 times minus 5b squared. So here we got minus, minus 5b squared, minus 5b squared. So minus 5b squared, I can break into these things, right? So how to break? So I can write this as, all right, I need to make a minus 4, right? So maybe I will take like 1 times, b times minus 5, b times minus 5b, b times minus 5b. So b times minus 5b. When you add these two, what happened? I'm going to get minus 4, right? I mean, b plus minus 5 is going to give me minus 4. So in this case, I can select this. So then how to write it? I will write a squared plus b, right? A squared plus b minus 5b minus 5b squared, right? So I selected these two terms from the here only, because when you multiply this one and this one, I get by b squared, right? Yeah. So here, I need to write a term here. Yeah. So now I can take a outside. So when you take a outside, what happened? A plus b, and from here I take minus 5a out, 5ab out. So minus 5b out. So then what is remaining? From 5ba, I take 5b out, then a is remaining. And from this one, I take 5b out, a b is remaining. So plus b is remaining. So then I take a plus b out. So a plus b, a minus 5b. Yes, we got one correct answer. Yes, some students got a minus b. I think this is check your answer. So we have a plus b, right? We take a out. So here a is remaining, and here we take minus 5 out. So a plus b is remaining. Okay, one more example. Let's do number 4, 3x squared plus 14x plus 15. Number 5, 6x squared plus x minus 15. Number 6, x squared plus 5 over 2x plus 1. Okay. Yes, correct. Shagin J, your answer is correct. You can go to the next one. Yes, Ramona, correct. Any other answers? We got two correct answers. Other students, can you send me the answer for the fourth one? Yes. Yes, Asmatullah, correct. Rumana, second one is correct. Sumaya, yes, correct answer for the first one. Shagin J, I think this is the answer to the second one. Yes, correct. Yes, Hofsa, that's right for the first one. Okay, any student want me to explain fourth one and fifth one? If not, I'll quickly do it. Okay, fourth one. Fourth one. 3x squared plus 14x plus 15, right? So always you multiply first and last. So it is going to be 3 times 15, which is 45. So 45. So just check from 45 how we are going to make a 15, right? You don't have to write each and every factor here, right? It will be very long thing. So just think how to make a 14. So 45, maybe let's like 1 times 45, no chance, right? 1 times 45, you cannot make a 40. No way. Then 2 times, no 45. Then 3 times 15. 3 times 15, no. Then 3 times 15 is not a chance, right? Then 4 times, no. 5 times 9. 5 times 9. 5 times 9. So from 5 times 9, I think you can make a 14, right? 9 plus 5 is 14. So no problem. So I'm going to write 3x squared plus 5x plus 9x plus 15. So you take 3 out, no, x outside. So you have 3x plus 5. Then plus you take 3 outside. You take 3 outside. You have 3x plus 5. So now you take 3x plus 5 outside. 3x plus 5 outside. You have x plus 3. Done. And fifth one, 6x squared plus x minus 15. So it is again 6 times 15, but it is minus, right? 6 times minus 15. So this is going to be a minus now. And again, you need to make a plus 1 here. So plus 1. So how to make a plus 1? Oh, sorry. So 6 times 15. So 6 times 15. How much? We have 6 times 5, 30. We have 6 times 1, 90, right? So from 90, how to make a plus 1? So you have, let's say, from 1, 2, 3. So this for you, you can write the answer is 3x plus 5, 3x plus 5, 2x minus 3. 3x plus 5, 2x minus 3. If anyone want me to explain, you can send me a message on the chat. And let's do the third one. Sorry, sixth one. So sixth one, x squared plus 5 over 2x plus 1, right? So here, I don't want to work with these fractions, right? So what I will do is I will take this half outside. I will take half outside. So when you take a half outside, here I don't have a half, right? So x squared. So this thing, what if I write half and I remove the half, right? I can write something like this, right? I mean, nothing happens, right? The x squared is equal to 2 times half times x squared, right? This 2 to this 2 cancel off. So even if the half is there, I mean, even if I put a half, I'm going to cancel it. So I'm doing no change. So when I take this half outside, a 2 is going to remain. So I can write 2x squared plus 5 over 2, there's a half, I take it out. So 5x is remain. Plus, here also I don't have a half, but I'm taking a half out. So then I can put a 2 here, right? So now it is going to be the same. So we have 2x squared plus 5x plus 2. You can find the factors. So we have 2 times 2 is 4, right? So you can write half times, within brackets you can solve. So you have 2x squared. So 2 times 2, 4. So 4 from 4 times 1, right? So we have 4x plus x plus 2. So then you can write half. 2x you can take out. X plus 2 plus, here I don't have anything to take, right? So simply I'm taking 1 out. So it is going to be x plus 2, right? So here same, like I took 1 now because there's nothing to take, right? But still this is going, this one and this one is going to be same. So it is going to be half times, I'm going to take x plus 2 out. I'm going to take x plus 2 out. What is remaining? 2x plus 1. So it is going to be half times x plus 2, 2x plus 1. That. Yeah. So can you explain the sixth one? Rumana, did you understand the sixth one? Just explain. Do you want me to explain again or did you understand? Or any other students? Okay, great. So if there anyone else need any explanation for these questions? Okay, some students, last one means this one, right? Okay, some students did not understand the last one. So let me do it again. So here, what I did was, I just wanted to take this half away. I wanted to take this 2, I mean, take that 2 away, to remove that 2. This in the denominator, I have a 2, right? So I'm just, this is like my method. I mean, you can follow any method, but still the final answer should be same. So here, I just wanted to remove this 2. But then because it will be easier for me to do the calculation, right? So here I can write this x squared like this, right? So 2 over 2 x squared plus, sorry, let me use the additional terms in red. So x squared plus 5 over 2 x plus 2 over 2, right? I can write this like this, right? There's no harm in writing it like this because 2 divided by 2 will give me 1. So it won't change. 5 divided by 2 is 5 divided by 2. Okay. So 2 divided by 2 again going to give me 1. So instead of 1, I just wrote 2 divided by 2. Instead 5 is already there. And here also instead of 1, I just wrote 2 divided by 2. So now I am going to take this half. This half, the denominator 2 is common, right? He also got a half. He also got a half. He also got a half. So I'm going to take the half outside. So when you get the half outside, what is remaining? 2x squared. 2x squared plus, from this one also you are going to take the half out, then 5x plus, from this one also you are going to take the half out, plus 2. So then you are going with the normal method. Did you understand now? Or you want me to go further? Up to here, is it okay? Okay, perfect. So now you can find, for this one, you can find the factors, right? You know how to find the factors for this one, right? But there, don't forget there's a half outside, right? There's a half outside, but still you can find the factors of this term. This thing you already know. You already know how to find it, right? So in that case, the final answer, so you can do your calculations and then simplifications, and you can find it is going to be 2x and x and 2x squared. Then it is going to be 2 and 1, right? Plus, plus. Right? So at the final answer, you can have a half outside. So half times this one times this. Okay. Okay. Okay, next we have difference of two squares. So I will just stop it from here, this part. So the next part is difference of two squares. Difference of two squares. So difference of two squares means, like, squares means what? A squared or B squared or C squared or 2 squared. So these all are squares. So difference means a subtraction, right? This is very important. I mean, you should have already learned this, but still, this is very important. The difference of two squares, even in many simplifications, you can apply this, right? So basically, difference means it should be a subtraction, right? I mean, something like we have 1 square minus B square. So you're subtracting two squares, right? So difference of two squares. So is this a difference of two squares? No, right? This is addition of two squares. This is addition of two squares. But this is a difference of two squares. So from one square, you are subtracting another square term. So this is called the difference of two squares. So basically, when you have two squares, a difference of two squares, you can simply write what? A squared minus B squared is always equal to A minus B times A plus B. This is basic. So whenever you see two squares are difference of two squares, you can simply write it A minus B, A plus B. Nothing complicated. I mean, the middle term is missing, right? At first we have a square term, at last we have a square term, in between something is missing. But still, if you have a difference of two squares, always, anytime, wherever you see, you can just write a minus b, a plus b. So finding the factors of squares, I mean the difference of two squares, is simple as that. Okay, so can you tell me the factors of 4x squared minus 9? Can you tell me the factors of 4x squared minus 9? Yes, 2x minus 3, 2x plus 3. Easy, right? So here you can write 2x, 4x squared, right? 4x squared means 2x, all things squared, and 9 means 3 squared, right? So now we have a difference of 2 squares. So it is going to be 2x minus 3, 2x plus 3, 2x minus 3, 2x plus 3. Okay, so then let's find next one. Number 2, x plus 2 squared minus y squared. X plus 2 squared minus y squared. Okay, we have one answer from Rumana, x plus 2 minus, so yeah, exactly. So here we have a square term, here we have a square. So this thing, whole thing squared minus this whole thing squared. So it is going to be x plus y is my first term. My second term is y, so minus y. Oh, sorry, not y, it's 2. So times x plus 2 plus y. Done. Simple. Next one. Third one. M plus 2 whole thing squared minus m plus 1 whole thing squared. Shaginjay, the factors, only these two factors, okay? You understood, right? Okay, m plus 2 minus m plus 1, m plus 2 minus, okay, let's see. So we have the first term and second term, right? So the first term is m plus 2. Okay, let me use like brackets, it will be clear, right? So here I have m plus 2 and plus m plus 1. Okay, so this is my first factor, and my second is going to be m plus 2 minus m plus 1. Right? Clear, right? First, this a minus b, a plus b. Let's write a the same way. A minus b, a plus b. A minus b, a plus b. A squared minus b squared. So a minus b, a plus b. So now simplify. So it is going to be, you can remove the brackets, right? So minus will go inside. So it is going to be m plus 2 minus m minus 1. M plus 2 minus m minus 1. Here it is going to be m plus 2 plus m plus 1. So it is going to be m minus m going to be cancelled off, right? So 2 minus 1 is 1. So we have only one factor. M plus m is going to be 2m plus m plus 1, 2m plus 3. So 2m plus 3 times m. That is the answer. Okay, next one. Fourth one. X to the power 4 minus 16. X to the power 4 minus 16. X to the power 4 minus 16. Okay, x minus 2, x plus 2, x squared plus 4. Okay, any other answers? Okay, so x to the power 4, right? By using the knowledge of indices, you know x to the power 4, let's write x to the power 4 minus 16. You can write this as x squared whole thing squared, isn't it? Right? X squared whole thing squared is going to give me x squared whole thing squared is going to give me x to the power 4, right? You understand this, right? I mean, instead of x to the power 4, you can write x squared whole thing squared. Minus 16 means 14, 4 squared, 4 squared. So now we have difference of 2 squares, right? But the first term is not x, but it is x squared whole thing squared minus 4 squared. So it is going to be x squared minus 4, x squared plus 4, right? X squared minus 4, x squared plus 4. Then again, you see here, we can factorize, right? Here again, there's a difference of 2 squares. So here you can write x squared minus 2 squared, x squared plus 4. So x squared minus 2 squared means what? X minus 2, x plus 2, x squared plus 4. Is it clear? Is it clear? Yes or no? I don't get any answers. Is it clear? Okay, perfect. Okay, so now time. Give me a second. Okay. So now for the algebraic fraction, algebraic factors of algebraic expressions, I will stop here this part. The rest of the questions in the tutorial that I have shared, there are several more questions. You can try them. Now let's move on to LCM of algebraic expressions. The lowest common multiple of algebraic expressions. Another easy section, but in grade 11, you have algebraic fractions lesson. So for algebraic fractions, this algebraic LCM is very important. So, and for LCM, the factors are very important. Okay, so next part is least common multiple, LCM of algebraic expressions. Algebraic expressions. Okay, so let's say let's first find LCM of 6, 8, and 12. Not algebraic expression, just 3 numbers. So LCM of 6, 8, and 12. So you know, 6 can be written as factors, right? So here factors are coming into play. So it is going to be 2 into 3, right? 2 into 3, right? So 6 you can make by 2 into 3, which means 2, you have to write them like this. So 2 to the power 1 multiplied by 3 to the power 1. Then 8. 8 can be written as 2 times 2, 4 times 2, right? So that is 2 to the power 3. And we have 12. So 12 can be written as 2 into 2, 4 into 3. 2 into 2, 4 into 3. That is 2 to the power 2 multiplied by 3 to the power 1. 3 to the power 1, right? So to find the LCM, what you're doing is, what you need to do is, you need to find the power, the same base power with the highest power. I mean, the same base with the highest power. So here we have power 2, here we have power 3, here we have power 1. So in that case, we will use power 3, right? So LCM is going to be what? 2 to the power 3 multiplied by 3 to the power 1, highest power of 3. So it is going to be 3 to the power 1. So it is going to be what? 2 times 2, 4 times 2, 8. 8 times 3 is going to give me 24. So this is the LCM of 6, 8, and 12. So LCM means by multiplying these 3 numbers, we can make the lowest number that we can make, right? So 24 we can make by 6, that is 6 times 4. 8 we can make 8 times 3, and 12, from 12 we can make 24 by 12 times 2. So this is the way you find the LCM for numbers, right? From smaller classes you should have learned this. So here we write the highest power, we take the highest power. So when it comes to algebraic fractions also, it is going to be the same. So let's do another example with numbers. So let's say we have 12, 18, and 24, right? 12, 18, and 24. So 12 you can write, 12 is equal to 2 times 2 times 4, right? 2 times 2 times 3. So that is 2 to the power 2 times 3 to the power 1. Then 18, you can write 2 times, then 3, 2 times 3, 6 times 3, right? 6 times 3. So that is 2 to the power 1 multiplied by 3 to the power 2. Then 24, you can write 24 divided by 2, 12. Then again, you have a 2. 2 times 2, 4 times 2, 8 times 3, right? So this means 2 to the power 3 multiplied by 3 to the power 1. Then you are selecting the highest powers. You are selecting the highest powers. So highest powers are going to be from this one, the highest power of 2 is going to be 3. So you are selecting for LCM, you are selecting 2 to the power 3 multiplied by highest power of 3 is going to be 2, right? So it is going to be 3 to the power 2. So it is going to be 2 times 2, 4 times 2, 8 multiplied by 3 times 3, 9. So 9 times 8 is going to give me 72. So 72 is the LCM of these three numbers. So let's now see how do you find of an algebraic expression. You better write it down for the numbers also. Okay. So number 3 is going to be 4a squared and 6ab and 8b. 6ab and 8b. So what is going to give me? So for 4a squared, you can make it like 2 times a times a, right? 2 times a, 2 times 2 times a times a. So that means 2 to the power 2 multiplied by a to the power 2, right? 2 to the power 2 multiplied by a to the power 2. Then 6ab. 6ab is 2 times 3 times a times b. 2 times 3 times a times b. So that is going to give me 2 to the power 1 multiplied by, I will write a here, right? A to the power 1 multiplied by 3 to the power 1 multiplied by b to the power 1, right? Then 8b. 8b, I can get 2 times 2 times 2 times 2, 2 times 2, 4 times 2, 8 times b. So it is going to be 2 to the power 3 multiplied by b to the power 1. 2 to the power 3 multiplied by b to the power 1. So now I can write LCM. LCM is going to be what? 2 to the power 2, 4. The highest power of 2. Highest power of 2 is 2 to the power 3, right? So I'm going to take 2 to the power 3 multiplied by a. Highest power of a is a squared. So I'm going to select this. A squared multiplied by highest power of 3. Highest power of 3 is 3. Multiplied by highest power of b is 1. B to the power 1. So it is going to be 2 times 2, 4 times 2, 8 times a squared times 3 times b. So it is going to be 8 times 3 is 24. So 24 a squared b. So this is the LCM of these three numbers. This is the LCM of these three numbers. Write it down. And write it down and find the LCM of 5xy, 10x squared y, and 2xy squared. Find the LCM. Find the LCM. Okay, so we have one answer, 10x squared y squared. Okay, any other answers? Okay, so Romana, 10x squared y. Okay. Okay, let's see. So let's take 5xy. So if you take 5xy, that means 5 to the power 1 multiplied by x to the power 1 multiplied by y to the power 1, right? Then 10x squared y, 10x squared y. So that means 2 to the power 1 multiplied by 5 to the power 1 multiplied by x to the power 2 multiplied by y to the power 1. And 2xy squared is 2 to the power 1 multiplied by x to the power 1 multiplied by y to the power 2, right? Now let us take the highest powers. So LCM is going to be 2 to the power 1 multiplied by 5 to the power 1 multiplied by, for x, the highest power is x squared. So x squared times, for y, it is y squared. So it is going to be 5 times 2 is going to be 10 x squared y. 10x squared y squared. 10x squared y squared. Okay, perfect. Now let's find for fifth one, different one. So let's say 15x squared, 20x plus 1, and 4a squared a minus b, whole thing squared. Okay, 60a squared from Shalin J. 60a squared, a squared, x plus 1, a minus b, whole thing squared. Yeah. Okay, so fifth one, we have 15 x squared. So 15x squared means what? So we have 3 to the power 1 multiplied by 5 to the power 1 multiplied by x squared. Then second one is 20x plus 1, 20x plus 1, which means 2 to the power 2 multiplied by 5 to the power 1, right? 4 times 5 is 20. So 2 to the power 2 multiplied by 5 multiplied by x plus 1 to the power 1. X plus 1 to the power 1. Those are the factors, right? So under factors lesson you learn. Then we have 4a squared a minus b whole thing squared. So here we have 4 means 2 to the power 2 multiplied by a squared. A squared, we don't have a squared here, right? So a squared multiplied by a minus b whole thing squared. A minus b whole thing squared. So LCM is going to be highest power of 2. Highest power of 2 is 2 to the power 2. So 2 to the power 2 multiplied by highest power of 3. Here we don't have 3. Here we don't have 3. It is going to be 3 to the power 1 multiplied by highest power of 5. 1, right? So 5 to the power 1 multiplied by highest power of x. We don't have x here, so it is going to be x squared. Highest power of a squared multiplied by highest power of x plus 1. It is x plus 1. And multiplied by highest power of a minus b whole thing squared. So you have to write each and every term, right, when finding the LCM. So we have 4 times 3, 12, 12 times 5, 60. So we have 60 x squared, a squared, x plus 1, a minus b whole thing squared. Done. So this is the LCM of those 3 numbers. Okay, let's do this. Three x minus 9, 4x, x minus 3, x squared minus 9. Let's find it. So now, basically, if you are okay with factors, if you are okay with what you call LCM, then for fractions, there's nothing, right? It is going to be very easy. Algebraic fractions is going to be very easy if you are okay with this basic theory. Okay, quickly tell me the answer. Now use the knowledge of factorizing. Okay, we have one answer. 12x, x minus 3, x plus 3. Any other answers? Okay. So for 3x minus 9, what are the factors? Maybe you can take 3 outside, right? So it is going to be 3x minus 3, right? 3x minus 3. So I will write it as a multiplication itself. So x minus 3. So the power is 1, Then 4x x minus 3, x minus 3. So this means like 4 times 4 to the power 1 times x to the power 1 times x minus 3 to the power 1. There's nothing complex here. Then x squared minus 9. X squared minus 9 means what? Difference of two squares, right? Here we have x squared, here we have a 3 squared. So that is going to be x minus 3 to the power 1 times x minus 3 to the power 1, x plus 3 to the power 1. So 3 to the power, so LCM is going to be 3 to the power 1 multiplied by 4 to the power 1 multiplied by, so 3 to the power 1, 4 to the power 1, then x to the power 1. So x to the power 1, x minus 3, highest power, x minus 3, x minus 3, x minus 3. So times highest power is 1, right? So x minus 3 to the power 1 multiplied by x plus 3 to the power 1, x plus 3 highest power. So nothing else remaining, right? Everything gone. So what is it? So it is going to be 3 times 4 is 12. 12 x multiplied by x minus 3, x plus 3. So this is the LCM of those three numbers. Okay. One more example. Then number 7, x squared minus 8x plus 15 and 2x squared minus x minus 15. Do it. This will be the last question. This will be the last sum. So do it. This might take a little time, so quickly do it. Try it as soon as possible. Let's see who is the first. Okay, we got one answer again from Sangin J. Okay, let me do. So last lesson, you learned how to find the factors, right? So for x squared minus 8x plus 15. So how to find it? So x squared minus 8x plus 15 would be what? So, 15. So from 15, how to make 8? So 5 times 3 minus 5 times minus 3, right? So 15 minus 5 minus 3 multiplied by minus 5 is going to give me plus 15, and when you add them is going to give me minus 8. So I will use these two. So it is going to give me x squared minus 3x minus 5x plus 15, right? So here, I mean, whenever you do factorization question, you can use these steps, right? But here, since this is a LCM question, maybe you can directly write. If you can directly write it. If you cannot directly write it, use the method, no problem. So how to write it directly? So you just put the bracket. It is going to be multiplication of two numbers, right? Then here we have x, right? So obviously the first term is going to be x and x, right? Because x times x, x squared you will get, right? When you remove the bracket, x times x is going to give me x squared. Then for 15, I selected, what did I select? -3 and -5, right? So it is going to be -3, -5. Then just check whether you get it. So x squared, right? X times -5, -5x, -3x is going to give me -6. 3 times 5 is going to give me +15. Okay, my answer is correct, right? So likewise, you can write it directly if you can, right? Still, if it is confusing, you can use the method. So for the second one, 2x squared minus x minus 15. So let's try to write for this one also. So 2x squared, how to make 2x squared? So if you want to make 2x squared, you have to multiply 2x by some number, right? 2x by some number. Then you need to make 2 times 15, 30, right? So 30. So how to make 30? So 30, let's from 30, how to make 1, -1. So you have, let's say it's -30. So 1 times 30, no. 2 times 15, no. 3 times 10, no. 4, 5. 5 times 6. So 5 times 6. So 1 is going to be minus, right? So let's reuse -5 times -6. 5 times -6. So I can put a 5 here. I can put a -6 here. So +5 here. So do I get the answer? 2x times 2x, 2x squared. 2x times -6 is going to give me -12 and 5. So no, I do not get the answer right like that, right? So it is wrong. So be careful when you do this method, right? So you have to be very careful. So in that case, let's use the method. So I will write 2x. So here I'm going to write plus 5x minus 6x minus 15, right? So what do I get? So I get, I'm going to take x out. So it is going to be 2x plus 5 minus 3. It is going to be 2x plus 5. So again, it is going to be, x minus 3 and 2x plus 5. So the factors of this one is x minus 3, x minus 5, and factors of this one is x minus 3, 2x plus 5. So you can find the LCM. LCM will be what? X minus 3, x minus 5, and 2x plus 5. 2x plus 5. Did you get the correct answer? Yeah, we have from Romana and also Shalin J. 2x plus 5, x minus 3, x minus, yeah, correct. So the method writing directly, better you use it whenever there is nothing here. Whenever the coefficient of x squared is 1, you can use this method. But whenever the coefficient is 2 or some other number, then better use the method. You will get the correct answer, right? So it will be confusing. If you want, just substitute and check whether you get the answer. But always keep in mind, you have to go backwards and check. Okay. So I will end because it's 9:10. So right now I will end the class now. So we still have algebraic fractions part remaining. So next week we will be doing algebraic fractions. So it won't actually be very that difficult. There's since now we are okay with factors, you are okay with LCM. So we're working with fractions is nothing. It's going to be easy. So yeah. So thank you very much. See you next week. Yes, you're welcome.